Hello everyone, welcome to the video lectures on engineering mechanics. In this video, I'm going to talk about equilibrium of rigid bodies. It's also called as equilibrium of coplanar concurrent force system. Okay, today I'm going to talk about these all the contents we have. That is introduction to equilibrium, Lamis theorem, the proof of Lamis theorem, how to prove the Lamis theorem, free body diagram, and some of the example based on free body diagram, equilibrium procedure, how to solve the problems which are based on equilibrium, and some of the problems which are based on sphere. First of all, what do you mean by an equilibrium? An object is in equilibrium when it is stationary or in steady translation. What exactly mean by is that when an object is in a state of equilibrium. Here I am talking about the state. When an object is at a state of equilibrium, either it's a state of stationary or either it is at a state of moving with a constant velocity. Why we can expect the equilibrium either in a state of stationary or either at a state of constant velocity? Because there is no any change in delta along any x direction or y direction or even along the rotational moment. So that's why we can expect the equilibrium under a particular condition. So here we have summation of f of x equal to 0, f of y equal to 0, and summation of moment will be equal to 0 when the body is at a state of equilibrium, which means that there is no any change which occurs along any of the direction, including the rotation of an object. Now, when a body is in equilibrium, it has neither translatory nor rotatory motion in any direction. Thus, the resultant force and the resultant couple are both are zero. As I mentioned earlier, there is no any moment as well as there is no any motion of the body along any of the direction. There is no any changes, that is delta will occurs in a body when the body is at a state of equilibrium. So therefore, when the body is at a state of equilibrium, it leads to the resultant. The total resultant in a body will be equal to 0. And also there is no any movement will occur in a body. Next I am going to talk about equilibrium. What exactly mean by equilibrium? As I mentioned, whenever we are talking about a state of equilibrium, even though when the forces are acting on a body, there should be some force which has to balance the body. To balance that particular body, obviously there should be an equal and opposite force should be acting on the particular body, which is equal to the same magnitude as the resultant. Here you see example, if I take an x-axis and y-axis are the two forces and the resultant of these two forces are the capital R. To keep these two systems in equilibrium, due to the resultant force which is acting along the rightward direction, there has to be some opposite force which is having the same magnitude as the resultant. This opposite single force is called as equilibrium. If I define an equilibrium, equilibrium is a single force which when added to a system of force brings the state of equilibrium. Hence, this force is of the same magnitude as the resultant, but it will always be acting in a opposite direction. The best example for this is if I give a tug of war game. If two teams are participating and there is no any further movement which is happening at the center, which means that the force which is applied by both the teams, both the opposite teams will be having the same magnitude, but they are participating in opposite direction. That's why the body or the entire team is at a state of equilibrium. There is no any movement of the rope which will happen at this particular point. So whenever I am talking about an equilibrium, equilibrium is a single force which has the same magnitude as a resultant, but it is always acting along the opposite direction of the resultant. Now, Lamis theorem. What is Lamis theorem? Basically, we can solve the equilibrium problem by using two methods. One is the analytical method and another one is the graphical method. The well-known theorem to solve the equilibrium problem on by using an analytical method is a Lami's theorem. What Lami's theorem states? It states that if three coplanar forces acting at a point which are in equilibrium, then each force is proportional to sine of the angle between the other two forces. Here you see there are three forces which are acting as P, Q and R, which frame an angle by the other two opposite forces. For the P force, which is alpha, and for Q, which is beta, and for R, it is gamma. So if I represent the Lami's theorem mathematically, which means that P by sine alpha, which is equal to Q by sine beta, which is equal to R by sine gamma. So how to prove the Lami's theorem? As we know that whenever we are talking about a Lami's theorem, it states that when three forces which are acting at a point, so make sure that whenever I want to apply the Lami's theorem, the condition should be applicable of three forces at a point. How to prove that? To prove the Lami's theorem, here we have taken and we have used the parallelogram law. What is parallelogram law? Parallelogram law says that when two forces which are acting at a point, then if you frame a parallelogram by, if you complete the parallelogram by drawing the other two sides of the two forces, then if you draw a diagonal from the same point where the forces are acting, this diagonal line indicates the resultant of the force. Here, to prove the Lami's theorem, basically we require three forces, and also to prove the Lami's theorem, make sure that the body is at a state of equilibrium. Here, as I consider 2 point P and Q and the resultant which is moving along the upward direction, which means that the body is moving along the upward direction. To nullify the body, to bring it to a state of equilibrium, I want to apply an opposite force which has a magnitude same as the resultant, but it should be acting along the opposite direction of the resultant. So here the OR represents an equilibrium, OC represent a resultant, P and Q represents the two forces, and OACB represents a parallelogram. Right? To prove that, consider a three coplanar forces, that is P, Q and R, which are acting at a point O. The opposite angle of the P, Q and R are alpha, beta and gamma respectively, as shown in the figure. As I mentioned, we know that the resultant of the two forces P and Q will be given by the diagonal OC, which is acting as a resultant, and the OD represents an equilibrium, which is having same magnitude as the resultant, but it will be acting along the opposite direction. Since these forces are in equilibrium, therefore the resultant of the force P and Q must be in line with OD, and which is equal to R, but it should be acting along the opposite direction. If you look at the geometry, before going to prove how it is, so first what I have to know to prove the Lami's theorem, I have to know three forces. I have to consider the three forces and the angle which made by the opposite two forces for a single force. All right. Now, from the geometry of the figure, we found that BC, which is equal to, which is representing a force P, and AC, which representing a force Q. As I mentioned, to know or to prove the Lami's theorem, we required the three forces and the angle made by them. Here, this force OA represents the P force, AC represents the Q force, and OC represents the resultant force. So totally, there are three forces which are acting. To prove the Lami's theorem, I want to know what is the angle made by these two forces, and what is the angle made by these two forces, and what is the angle made by these two forces. Because here the triangle OAC, which is equal to the triangle OBC, right? So from the geometry, we have to figure out what is the angle at A, what is the angle at C, and what is the angle at O. To prove that, here we have taken the angle AOC. What is the angle at O? To prove that, we have taken a triangle AOC. Here you see the entire angle from O, which is 180 degree till here, out of which the angle made by the force P and R will be beta. So what is the angle which formed here? The angle should be 180 minus beta. The same way, what is the angle at ACO? To know what is the angle at ACO, as I mentioned, both the triangle OAC and OBC are equal. So to know what is the angle made by this particular point, so what I have considered? I have considered a triangle BOC. So which is equal to total 180 degree is there from this particular straight line, 180 minus the angle made by Q force. The angle made by the Q force is, here it is alpha. So totally which is equal to 180 minus alpha. 180 minus alpha gives this angle. This angle, if I taken an opposite angle, then this is the angle which there at a point C. Now I want to know what is the angle which made by OAC or CAO. To know what is the angle which made by CAO, which is equal to the total internal angle of a triangle is 180 degree. 180 minus the angle made by AOC plus the angle made by ACO. So 180 degree is the internal angle, out of which I am going to deduct the angle which made by AOC and ACO. So if I continue, here you see the CAO, the angle at A, which is equal to 180 minus the angle which formed by O point plus the angle which made by C point. If we simplify it, 180 minus beta is the angle at AOC and 180 minus alpha is the angle at ACO. If you simplify further, we will get alpha plus beta minus 180 degree is the angle which made by the A point. Here you see the angle which made by O point, which is equal to 180 minus beta, the angle which is made at a point C, which is equal to 180 minus alpha, and the angle which made at A point, which is equal to 180 minus alpha plus beta. Now, subtracting the 180 degree from both the sides from this equation, that is alpha plus beta plus gamma, which is equal to 360 degree, is the entire angle of the circle. So if I subtract 180 degree from this particular equation, so I will get alpha plus beta minus 180 plus gamma, which is equal to 360 minus 180 degree. So I know the angle at CAO, which is equal to alpha plus beta minus 180 degree, which implies 180 minus gamma. So therefore, we know that in a triangle AOC, OA by sine of the angle ACO, that is here you see OA. What is OA? OA is this one. If this is the first point P, if one force, then what is the opposite angle? Opposite angle is this one. So if this is the force, the angle made by other two forces are this one. So OA by sine of the angle made by C, and AC by what? AC is this force, that is Q force. What is the opposite angle? This is the opposite angle made by these two forces. So which is equal to AC by the angle AOC, and the third one, this is the third force. If this is the third force, what is the opposite angle? This is the opposite angle, which is OC by sine of the angle at A. The angle at A is 180 minus alpha plus beta. So that is what we have written here. That is at OA 180 minus alpha, at AC 180 minus beta, and OC 180 minus gamma. What is 180 minus gamma? 180 minus gamma is the angle made at A point. So at A point, we know that alpha plus beta minus 180 degree, which is equal to the angle 180 minus gamma, we can easily represent. So therefore, OA is a P force, sine of 180 minus alpha is sine alpha, AC is Q by sine beta, and OC is R by sine gamma. Okay, next one. The next topic is free body diagram. What exactly mean by free body diagram? As the term itself indicating that free body diagram is the diagrammatic representation of all the forces which are acting on the body. The free body diagram is basically defined as the diagrammatic representation of all the force and couple or moment which is acting on a body. It should be diagrammatically represented. How to draw the free body diagram? To draw the free body diagram, first we have to draw an outline shape of a body. First we have to draw outline shape of the body. Then represent or show all the forces and couple moments which are acting on the body. Third one, label all the loadings and specify their direction relative to x and y axis. Indicate the dimension of the body necessary for computing the moment of forces. So here when I'm talking about free body diagram, which means that it is a diagrammatic representation of all the forces which are acting on a body is called free body diagram. To draw a free body diagram, first step I want to draw is draw the outline shape of a body. Second thing, represent all the forces including the self weight and moments which are acting on the body. Third one, label all the loadings. What is the magnitude of the loading or forces and specify that direction with respect to x and y axis. Then indicate the dimension of the body to compute what are the unknown forces which are acting on the body. Okay, here I have given some of the examples of free body diagram. If you look at the first diagram, here simply a block is rested over the surface. When the block is rested over a surface, to draw the free body diagram, you look here. So first I want to draw the outline shape of a body, that is the block I have written. Then I have written the self weight of the body as, which is always acting downward, so I have written it as W. And to keep this block in equilibrium, then definitely with against the self weight, there should be a opposite reactional force should act. That opposite reactional force is R. So this indicates the free body diagram of the block. Next one, here I have given an example of a roller which is hanged to the wall by using a string, right? So to draw the free body diagram, first I want to write the outline shape of a body. Isolate the body. I isolated the body here and I draw the outline of a body. First thing I want to write what is the self weight. Next one, to keep this roller in equilibrium along with tied with the string, it has rested on a wall. So when it is in contact with any object is in contact with the contact surface, then definitely there will be a reactional force which is always acts normal to the particular surface. Here also you see when the block is rested on a contact surface, whenever the body is at a contact surface, it will always, there will be a reaction which developed by the contact surface which will act normal to the particular object. So here the roller has been touched the wall, so there is a contact surface and the contact surface having a reaction R which is acting on the body. And also we know that we have tied the roller to the wall by using a string. That string is having a tension which is acting upwards. It is written as capital T. The third example, spear in a groove. This is the kind of an example even we can get for notches. Right? Here you see a groove is rested by using the two V-shaped surface, that is a V-shaped contact surface which having a contact surface at point A and B. So if I want to draw the free body diagram, first I am isolating the body, that is I am going to draw a circle, then I am going to draw what is the self weight of the particular sphere. Then as I mentioned, wherever the contact surface exists, there will be a reactional force which will always act normal to the particular contact surface. So there is a one reaction at A points that I have written as RA. And there is another reaction which will develop at the another contact surface which is acting normal to it, so which is RB. right? So this is the free body diagram for the third example. Next one, here I will represent a small cantilever beam which is acted by two forces F1 and F2. Here you see, first I have isolated the body and I will draw a cantilever beam. First I have written what is the self weight of the beam, that is W. Then I am representing the forces acting on it at the same particular point, that is F1 and F2. Whenever there is a cantilever beam, it is basically supported by a fixed support. When there is a fixed support, basically three types of reaction will develop. That is, I have represented, one is upward force and another one is a rightward or leftward force, and there will be one moment will be acting against the force. So that is what we have represented here. Next one, that is the fourth one. Here we have given the fifth example, that is here a ladder which is rested on two walls when along with the two forces which are acting on the ladder. How to represent the free body diagram? To represent the free body diagram, I have isolated the body and here I have written the contact point A and the contact point B for the wall. And here you see there are two forces which are acting, F1 and F2. And also I mentioned the self weight of the ladder, which is equal to W, and the reaction RA and RB. Next one is how to solve the problems which you are dealing with equilibrium. The first step to solve the free body diagram, first step to solve the equilibrium is to draw free body diagram. The very first point is to draw free body diagram. Next, apply the Lamis theorem. Check, or rather than saying apply, check for the Lamis theorem, whether the particular problem is dealing with the Lamis theorem or not. How to check the Lamis theorem? Which means that there should be three forces which should be acting at a point. If not, then use the equations of equilibrium. As we know, when the body is in equilibrium, there is no any movement along x direction and y direction for coplanar concurrent force system. If it is a non-coplanar concurrent force system, then there will be a existence of f of x equal to 0, f of y equal to 0, and summation of moment will be equal to 0 only for non-concurrent coplanar force system. Right. Next, applying the force of equilibrium equation, represent along x and y axis of the line will provide the simplest resolution of the force into their x and y components. Then finally, whatever the answer you are obtaining, if it is at a negative scalar or the couple magnitude is negative, then indicate that the direction we have assumed it is in a opposite direction. So change it to the original direction. So what is the basic procedure to solve the equilibrium problem? First thing, we have to draw free body diagram. Second thing, apply the Lamis theorem. Check for the Lamis theorem, whether the three forces are acting at a point or not. If not, then use the equations of equilibrium for coplanar concurrent force system, that is summation of f of x equal to 0, f of y equal to 0. If it is a non-concurrent coplanar system, along with the f of x and f of y, there will be a summation of moment will be equal to 0. Then resolve the forces to get the unknown. Whatever the unknowns you obtained, if it is indicating a negative sense, which means that the direction we have assumed for the forces will be in an opposite direction. Next one, to solve the problems which are based on sphere problem. So here one important conditions we has to know. What is that important condition? When two planes are acting perpendicular to each other, then if one force makes an angle theta with respect to horizontal, then the same angle theta will form with respect to vertical, which means that when two forces which are acting at a particular point, then if one plane which makes an angle theta with respect to horizontal, then the other plane will make the same theta with respect to vertical. How to prove that? You see here, when two planes, these are the two planes which are acting perpendicular to each other, then if the first plane which is making an angle theta with respect to horizontal, then the same theta will form with respect to vertical in the another plane. Okay, let me repeat again. When two forces or two planes which are acting perpendicular to each other, then if one plane makes an angle theta with respect to horizontal, the same theta will form with respect to vertical on the other plane. Okay, from next lecture we'll be talking about what all the problems which are based on equilibrium equation.